everybody, welcome to Matthews. Today I have take a topic on remainder and factor theorem, two important theorems in polynomial chapter from the lower grade. Today we will be exploring the concept behind it, and we will be solving examples related to it. So first of all, what is a polynomial? Say polynomial p of x. It is an algebraic expression where the power of the variable is a whole number. This power, this, and this. These all are whole number because any algebraic expression, say a, it can be a squared x3 by 2 plus 2x 1 by 4, etc. This is an algebraic expression, but this is not a polynomial because in polynomial the degree of the variable must be a whole number. Note, all algebraic expressions are not polynomial, but polynomials are algebraic expression. I would also like to tell about what is difference between algebraic expression and algebraic equation. Suppose when we are saying p of x as algebraic expression, say x square plus 3x plus 1. So this is an algebraic expression. But when we equate the algebraic expression equal to some constant k, where k is constant, then this signifies the algebraic equation. One more thing before moving on to our main topic, degree of polynomial. Degree of polynomial. So what is degree of polynomial? Degree of polynomial is the highest power of variable in polynomial. Example, 0x raised to 7 plus 3x raised to 5 minus 5x square. So in this, degree of polynomial will be 4. You might be considering that the maximum power on the variable has is 7, but it is multiplied with 0, so the whole thing is 0, and what we will be left with is the 3x raised to power 4 minus 5x square. So degree of this polynomial will be 4. Okay, moving on to our main topic, that is remainder theorem. What you would say first, we will read it. If px is any polynomial and a is any real number, then remainder when px is divided by x minus a is given by p of a. X minus a means here it is linear polynomial. Degree is 1. So remainder theorem we apply for the linear polynomial, basically division by the linear polynomial. Okay. So for example, say p of x is equal to x square minus 3x plus 1. This is our polynomial equation, and we want to figure out its remainder when it is divided by x minus 1. Sorry, this is 1, x minus 1. So we want to divide this polynomial p of x by x minus 1, and we want to find its remainder. So simply what we will do, x minus 1 equal to 0, we will equate our linear polynomial by which we are dividing, and from here we get the value of x to be 1. So we will simply put it over here, x square, it will be 1 square minus 3 plus 1. So basically it gives minus 1, right? So our remainder in this case is minus 1. If I talk about its proof, so if I talk about its proof, that is remainder theorem proof. So basically we know that Euclidean division algorithm say that of x is equal to q of x and g of x plus r of x. Basically what it is, dividend the thing which we are dividing, quotient into divisor, this function remainder. P of x is dividend equal to quotient into divisor plus remainder. This is our division algorithm, and so here over here P of x is our dividend, the thing which we are dividing, it is Px, and by which we are dividing is x minus a, right? We are dividing with x minus a, so our g of x is x minus a. So let me write it again. Of x we don't know, but we know that this thing plus r of x. So if we put the value of x, like putting the value of x to be a, so what we will get is that q of a into, if we are putting it on the LHS, we need to put it all over on the RHS also. So q of a into x value over here a minus a plus r of a. So basically this thing is 0. So p of a is r of a, means putting the value of x minus a, that is x minus a equal to 0. So from here we get the value of x equal to a. So if we put it in the, I'm sorry, if we put the value of x in p of x, we get remainder. This is the very simple proof of the remainder theorem. Going ahead, we will also learn about the factor theorem, and you will see that they both are related. Like when remainder is 0, when we are dividing a dividend by some divisor, if we are getting a remainder to be 0, then we say that it is a perfect divisor, means it is a factor of it. Right? So okay, that we will see in the factor theorem. So moving on next. So these are the few important things that we need to have in mind so that we can solve the question easily. It says if p of a equal to 0, we say that a is a 0 of the polynomial. What is 0 of polynomial? 0 of polynomial is that value, basically, say p of x is our some algebraic expression. So if we put the value t in it, so if the algebraic expression turns to 0, so we say that t is a 0 of polynomial. So if p of a equal to 0, we say that a is a 0 polynomial. Basically, it also signifies that p of a is what? If the remainder equal to 0, we are getting remainder to be 0. So we say that a is the, a is the 0 of the polynomial. So the very first point is that it is clear. You will get more clarity when we will apply these things in the question side. So moving on to the next point, it says p of x is a polynomial and a is a 0 of px. Then p of x can be written as x minus a into q of x. This is basically what it is saying, that p of x, it will be x minus a into q of x, dividend, divisor, this is some quotient, and remainder here it will be 0 because it is given that a is the 0 of polynomial. So if we put p of a, it will get p of a is what? This is remainder, right? Our remainder is 0. So basically we can write our polynomial p of x as x minus a into q of x. I will take an example for clarity of this in the next page. So if p of x is divided by ax plus b, then the remainder is given by this thing. Now 3 and 4 point are basically same only, but there is a sign of minus. So what I have told in the beginning, that we will equate it to 0. The thing by which we are dividing is equating the divisor equal to 0. So from here we get the value of x to be minus b by a, and putting it back in this, putting this expression over here, we get remainder, right? So it is given that p of minus b by a will get its remainder. And similarly over here, if we equate ax minus b equal to 0, so from here we get x equal to b by a, and if we put b by a, then we get the value of remainder, right? So I have explained all these 4 points which are very important and we need to consider while solving the questions related to remainder here. Moving on next. For example, say p of x is px square minus 9x. So say over here that's minus 1. Okay. So dividing by x minus 2, remainder will be what? So our step one is equating the divisor equal to 0. Here our divisor is linear. Very important. Keep in mind that our divisor is linear. So equating the divisor equal to 0. So x minus 2 equal to 0. We get x value as 2. Step 2. The value we get in p of x to get remainder. So p of 2 is how much? 3 into 2 square minus 9 into 2 minus 1. So it's 4 3 12 minus 18 minus 1. So it's minus 7. So minus 7 is our remainder. So we can write this p of x as some quotient q of x into x minus 2 minus 7. So basically what is this? We are dividing by x minus 2 to p of x, and we get over here some q of x, and in last we get minus 7 and remainder, right? So q of x is the quotient. Like we can also figure out what is q of x. Our p of x was 3x square minus 9x minus 1, and our g of x, which is basically divisor. So x minus 2 into 3x square minus 9x minus 1. So this is plus 6 and subtracting. Okay. So what we can write p of x as x minus 2 into 3x minus 3 in minus 7. This is our divisor, this is our quotient, and this is remainder, and this was dividend. So I hope you understand this question. One more example. Say x minus 2 gives remainder equal to k, and the wait, a polynomial p of x when divided by g of x, quotient is and the remainder is a. Express p of x in terms of g of x, u of x, and remainder. This is our q of x. Okay. So saying p of x, we need to express it in terms of g of x, q of x, and our remainder. So what we know that dividend equal to divisor into quotient plus remainder. So dividend that we are dividing is p of x. It is when divided by 2x minus 1. Get quotient to be 2x plus 1, and then remainder was a. So our polynomial p of x is it is a minus b into a plus b. So it will be simply a square minus b square. So 4x square plus a minus 1 p of x. This is a minus 1. This is minus. So this is our polynomial p of x. Moving on next. So what is factor theorem? That I have previously told that when the remainder equal to 0, we say that it is the factor of the polynomial. So if p of x is a polynomial of degree n greater than 1, and a be any real number such that p of a is 0. What is p of a? P of a is remainder. And x minus a is a factor of p. Simply we can say that first let's see in algebra. I mean basically what we know that suppose 12 is divided by a such that uh, remainder is 0. Remainder is 0. So 12 divided by k. K can be 1, 2, 3, 4, 6, and 12. So these are the possible values of k for which we will be getting remainder to be 0. And you will see that what all these are. These are the factors of this. Factors. So when the remainder is 0, we say that it will be a factor of it. So basically it's saying that p of x is equal to q of x into g of x plus r of x. So if r of x is 0, it is 0. So we say that q of g of x is factor of it, right? I hope you are getting the meaning of factor. What does it mean by factor? And factor theorem and remainder theorem are nothing different. They both are the same thing. I would say that the factor theorem is basically a special case of remainder theorem. When remainder is 0, we say that um, when the remainder is 0, we say that the thing by which we are dividing, basically our g of x, it is a factor of p of x, right? So it is a special case of factor theorem, I mean remainder theorem. So few important points that we need to take care. It says that if p of minus a equal to 0, x plus a is a factor of p of x. You might be thinking that here it is minus, why not p of a? So basically what I have told you in the remainder theorem, that our divisor, that is linear expression, equating it to 0, what we get x minus a over here, and this minus a we will put in p of x to get remainder p of x. So if we will put p of minus a, and if it turns to be 0, we say that this divisor is factor of p of x, right? So first point is clear. The second point, it says that minus b by a equal to 0, then a of x plus. Basically, it is saying that this is remainder, and remainder equal to 0. So ax plus b is a factor. Ax plus b equal to 0. So x equal to minus b by a. So if we put it in, and if it is 0, so this is factor. Similarly, the third point can be understood that if we equate it to 0, we will be getting b by a equal to x, and we have put p of x, value of x to be b by a, and we are getting it to 0. Then we are saying it. One very important thing, that if the remainder is 0, then we are saying it to be factor. Or you can also say that if it is a factor, then the remainder must be 0. For example, we are saying that if x minus 1 is factor of x square plus 2x plus 1, then say it to be p of x, and we are saying it to be factor, right? So let me put the value of, from here we get x value 1. So p of 1 equal to 1 square plus 2. Oh, I'm sorry. It should be p of x is x square minus 2x plus 1. So basically, what we get from here is 0. And you can also see that this is the minus 1 whole square. So basically, p of 1 is 0 when x minus 1 is factor. So the first, second, and third point is clear. Moving on to next point. It says that if the sum of the coefficient of a polynomial is 0, then x minus 1 is one of its factor. So say if the sum of all coefficient of a polynomial is 0, hence what is the coefficient? 2 minus 3 plus 1 equal to 0. So we can say that x minus 1 is factor. This is not a rocket science, like from where did it get that. It is basically important, and I would say it is very useful in solving questions, because if you will see that the sum of coefficient turns out to be 0, so you get directly that x minus 1 will be a factor. Basically, we are putting x value as 1, and putting the value of multiplying any number with 1 does not have any significance, because it will be the same number. So simply we are saying that if the sum of the coefficient of the polynomial turns out to be 0, then you can directly say that x minus 1 is one of its factor. Now for the fifth point, I'm clearing the space. Alright. So the fifth point says that if the sum of coefficient of odd powers of x is equal to sum of coefficient of even powers of x, then one of the factor of the polynomial is p of x plus 1. So you can see that we are dividing by x plus 1. So we have to put x equal to minus 1 in p of x, right? So say p of x is to be ax cube minus 2x square minus 1, I mean minus x plus 0. Basically this is not. So here odd means odd power of x. Odd power of x is x cube and x is to 1. Sum of the coefficient 3 plus minus 1. So it is 2. Basically it is plus 2x square. And sum of even power. Even power, here it is only x square So it is 2. And if these things are equal, then we say that x plus 1 is a factor. Basically, if you will put minus 1 over here, so what you will get that minus 1 cube plus 3 raised to minus 1 square minus minus 1. So this is minus 3. Okay. So this is minus 3 plus 2, and then this is basically plus 1. So putting value of minus 1 in the p of x, we get it to be 0. So we say that x plus 1 is the factor. I would like to have more clarity on this by because it comes like for x minus 1 it is clear, but for x plus 1 it is like it sometimes seem like how like why the coefficient of odd power not the even and odd power both together. So let me clear it out. P of x to be 7x raised to power 9 plus 3x raised to power 8 plus 5x raised to power 4 plus 3x raised to power 3 plus 2x square plus 2x plus 2. Okay, so this is our polynomial p of x. If we will put the value of p of minus 1, from here we get x value as minus 1. Okay, so if we will put x equal to minus 1 in this, what we will get? That basically the minus will have an impact on this because it's an odd power. So basically it will just pop out over here. So it will be minus 7, right? And but the even powers have no impact. Even powers have no impact. So it will be simply 3 plus 5 plus 2 plus 2. Okay, but odd powers will just pop out because if we will put minus 1 over here, it will just pop out. It will be minus 3. So minus 7 minus 3 minus 2. So it is how much? 12 minus 12 equal to 0. Are you saying sum of odd powers? This was our odd powers, and sum of even powers when they are equal. At last, what we want is that we need to have remainder equal to 0. So for remainder equal to 0, if we have the sum of even powers, here it is sum of coefficient of even powers. If it is equal to sum of coefficient of odd powers, if it is odd power. So if for all odd powers, the value of minus minus 1 will it will just come out of the box and it will be negative, right? Because here you can see that earlier our sum was 12, coefficient sum was 12, but putting the value of x equal to minus 1, what we get finally is minus 12. So basically it will be negative of this. So negative of even power sum, and putting it now shifting it onto the left hand side, it will negative, it will get positive, right? Negative will get positive. So we will have on the RHS 0 and on LHS it will be sum of all coefficient and it is equal to 0. So basically one thing very important that sometimes you miss the this thing, x raised to 0. Constant terms come under even power because it is x raised to 0 into some constant, say over here it is 2. So 0 is an even number. So constant term come under the even power thing. That's why I have added this 2 on this, and this 2 is from this. So I hope it is clear. So let's move on to the questions. You will find that questions by doing questions you will get more clarity on what we have studied. So the question says that find a common factor of the quadratic polynomial 3x square minus x minus 10 and 2x square minus x minus 6. So p of x said to be p1 of x. This is p2x 2x square minus x minus 6. You need to you can do like in this thing you can factorize it. If you will see by middle term splitting, this is minus 30 and the sum needs to be minus 1. So basically it is minus 3x square minus 6x plus 5x minus 10. So it is 3x plus 5 into x minus 2, and factorizing this, the product needs to be 12 minus 12 and the sum to be minus 1. So this is basically x plus 3 into x minus 2. You can see that in P1 of x and P2 of x, x minus 2 is the common thing. And you can also verify that putting the value of x equal to 0 in this and this, both will turn out to be 0. Like 3 into 4, 12, minus 2 minus 10, so it is 0. And 2 into 4, 8 minus 2 minus 6, it is also 0. So x minus 2, since it is a factor, it will turn the remainder to be 0. And x minus 2 is the common factor. So our answer is x minus 2. Now the second question says that find the linear polynomial in x which when divided by x minus 3. We need to find out the linear polynomial in x. So the degree is 1. Degree of p of x to be 1, which when divided by x minus 3 leaves the remainder 6 and is exactly divisible by x plus 3. So say p of x to be, it is divided by x minus 3 into q of x some remainder plus 6. Since p of x is also a linear polynomial and here it is also linear polynomial, q of x will be a constant term, because if it will be um, um, because if it is not a constant term, it, say for example it is linear term, so linear into linear will give quadratic, means basically we will have degree to be 2, but we need p of x to have degree of 1. So q of x will be a constant term only. So writing it over here, p of x equal to, see this constant to be k, so k x minus 3 plus 6, and we know that it is exactly divisible by x plus 3. What does it mean? X plus 3 exactly divisible means x plus 3 is the factor of p of x. So if it is a factor, equating it to be equal to 0, we get x minus 3. So putting value of x equal to minus 3, we will get 0, right? So let me do it over here. Minus 3 minus 6 plus 6. So what it is? Minus 6 plus 6 equal to 0. So value of k turns out to be 1. So our polynomial p of x is x minus 3 plus 6, which is basically p of x is equal to x plus 3. So hope it is clear that p of x is basically the same thing. We know that 12 is a factor of 12, right? 12 can be a factor of 12. Similarly, in this question, we get the same thing, that 12 is a factor of 12. So this question is clear. Moving on to the next question. So the next question says that if f of x plus 2 equal to x square plus 7x minus 13, then find the remainder when f of x is divided by x plus 2. So we need to divide by x plus 2, means basically we need to have this substituted in this place. We need to put minus 2 in this place, and we need to find the remainder. So whatever we will be putting, that basically p of minus 2 will be giving remainder, right? So we have given f of x plus 2. This is not f of x, this is f of x plus 2. If you will simply put x equal to minus 2 in this, so minus 2 plus 2, it is giving f of 0, not f of minus 2. We need what? We need minus to be substituted. So we will not be doing this. Instead, we will put that value of x. So we need to this thing, right? So x plus 2 value we need minus 2. So x value it will be minus 4. So we need to substitute value of x equal to minus 4. So it is f of minus 2, and in the expression it will be minus 4 square plus 7 into minus 4 minus 13. What we get is 16 minus 28 minus 13. So 3 minus 28 minus 25. So this is the answer. In this question, the only thing that was important, that it may confuse for the first timer, like the person who is solving it for the first time, that he may get confused that why we are not putting minus 2 directly, because we are dividing by x plus 2, so we get x equal to minus 2. So one thing for need to see, like when we say that p of a, right, p of a equal to 0, then x minus a is factor, right? So we are putting a over here, we are putting a over here, but if we will directly put minus 2, so it will be f of 0. F of 0 is not same as f of minus 2. This is not same. So we need to find out such value of x such that putting it over here we get f of minus 2. I hope I have explained it nicely. So here we have the next question. It says a quadratic polynomial in x gives the remainder as 4 and 7 respectively when divided by x plus 1 and x minus 2. Also it is divisible by x minus 1. Find the quadratic polynomial. Since our p of x is quadratic, degree of polynomial degree equal to 2. P of x. Since it is given that it is divisible by x minus 1, so it can be written as x minus 1 times q of x plus 0. Since it is divisible, so the remainder will be 0. And this is having degree 2, this is having degree 1. So it will also have degree 1. So that when multiplied, it will turn out to in degree 2. So say q of x, that is our quotient to be ax plus b. This is a linear, basically degree 1 polynomial. So p of x is equal to x minus 1 times ax plus b. So if we will put value of x equal to minus 1 dividing by x plus 1, so we need to put x value as minus 1 and over here we will need to put x value as 2. So p of minus 1 will be how much? Minus 1 into a into minus 1 plus b. So basically it is minus 2 into minus a plus b and this thing equal to 4 and p of 2 is equal to 2 minus 1 a into 2 plus b. So basically it is 2a plus b and this thing equal to 7. So here we get that 2a minus 2b equal to 4. So a minus b equal to 2. I'm just doing this thing over here and this thing over here. And we know that 2a plus b equal to 7. So value, if we will add it, so this will get cancelled. 3a value to be 9 and a value to be 3. So value of a equal to 3 and value of b will be how much? Value of b will be 1 because if this is 3, it turns out to be 1 so that RHS will be 2. So basically we get that I will have to erase this part. Here it is p of x equal to this. So p of x equal to x minus 1 times what is the value of a? It is 3 plus b. Sorry, it will be value of a 3 and b of value is 1. It will be 3x plus 1. X minus 1 into 3x plus 1. So multiplying it, we will get 3x square minus 3x plus x minus 1. 3x square minus 2x minus 1. So this is our polynomial. Basically, this is our quadratic polynomial. I hope you have understood this. Moving on to the next question. Yeah. So the next question says that if x minus 2 and x minus 3 are two factors of f of x, which is this, and then find the remainder of f of x when divided by x minus 5. So basically, it is given that f of x equal to x cube plus ax plus b, and it is given that these are the two factors. Again, if this is factor, putting the value of x equal to 2 will turn out to be f of this value to be 0, and putting the value of x equal to 3, it will limit the expression to be 0. So we will do that thing only. F of 2 value will be 2 cube plus 2a plus b equal to 0, and f of 3 will be 3 cube plus 3a plus b, right? So from here we get that 2a plus b is minus 8 and 3a plus b is minus 27. So we will subtract it. This will get cancelled. It will be minus a equal to this is 19. So value of a turns out to be minus 19. Minus a is 19. So value of a will be minus 19. So if a is minus 19, so we know that 2a plus b is minus 8. Sorry. So this is minus 38 plus b equal to minus 8. So value of b turns out to be minus 8 plus 38, which is 30. Value of b will be 30. So our f of x is how much? It is x cube minus 19x plus 30. We need to find the remainder when it is divided by x minus 5. So we will be putting value of x equal to 5 in the polynomial f of x so that we will get the remainder. So putting the value of x equal to it is this is 30 plus 30 60. So we get the answer to be 60. Moving on to next question. So the question is, if the polynomial f of x equal to x square plus 5x minus p and g of x equal to this have a common factor, then find the common factor. Okay. Say the common factor to be x minus k. I do not know the value of k. Like so we need to assume it to be in general that k is any real number. So x minus k will be its factor. So if it is factor of f of x, which is and of g of x, if this is factor, then putting the value of this thing, which is basically x equal to k, we get f of x equal to 0 and g of x equal to 0. So f of k equal to 0, I mean f of k equal to k square plus 5k minus p, and from over here we get g of k equal to k square minus 2k plus 6p, and this both these are equal to 0. So you can see from over here that since they both are equal to 0, we can equate it, right? So equating it, x square k square will get cancelled by k square, and it will be 7k equal to 7p. So value of k equal to p only, right? So our factor is x minus p. Okay, fine. So now again we will do the same thing, because f of if it is a factor, then putting the value of x equal to p, it will turn out to be f of x equal to 0 and g of x equal to 0. So f of p will be how much? It will be p square plus 5p minus p, and g of p will be how much? It will be p square minus 2p plus 6p. So from over here we get that p square plus 4p equal to 0. From over here we get the same thing only. From over here also we are getting the value of. So our LHS is this, and we need to turn it to be equal to RHS, that is equal to 0. So it can be possible for either p equal to 0 or p equal to minus 4. If p is minus 4, then this bracket will be 0 and 0 into something will turn out to be 0. But if this is 0, so 0 into something is 0. So the value of p equal to 0 or minus 4. So we know that we have considered x minus k to the common factor, and it turns out, well, after solving that, x k equal to p. So x minus p is common factor, and value of p is either 0, so x minus 0, or x minus 4. So either x is the common factor or x plus 4 is the common factor. So either this is factor or this is factor. So answer will be either B or C is the common factor. Moving on to the next question. It says that given f of x is a cubic polynomial in x, if f of x is divided by x plus 3, x plus 4, and x plus 5, and x plus 6, then it leaves the remainder to be 0, 0, 4, 6. 0, 0 means this signifies it to be factor. So f of x is what? Since it 0 comes from this and this. So x plus 3 into x plus 4 into g of x, right? This will be the polynomial function. Here remainder will be 0, because if we will divide it by x plus 3, basically minus 3 we will put, this will be 0 and this whole will be 0. And again x plus 4 by division by x plus 4, we will be putting x value to be minus 4. So this will be 0 and 0 into whole thing will turn out to be 0. So f of x, it is given as this is cubic. So this is linear, this is linear. So it will be also linear. So that product will turn out to be cubic. So g of x, assume it to be x plus b. Now it is given that dividing by x plus 5 turns the remainder to be 4, and dividing by x plus 6 turns the remainder to be 6. So we know that our f of x is x plus 3 into x plus 4 into x plus b. So dividing by x plus 5, x equal to minus 5 we will put. So minus 5, it will be minus 2 into minus 5 plus 4 is minus 1 into a into minus 5 plus b. So this is 2 into minus 5a plus b. Basically minus 10a plus 2b equal to 0. Sorry, this is not 0. Sorry. It is not given that it is a remainder. I mean, it is not given that it is factor. So it will turn out to be 4. So minus 10 plus 2b equal to 4. So I'm writing over here b equal to 4. Fine. And similarly, putting the value of from here x equal to minus 6, we get minus 6 plus 3 is minus 3 into minus 6 plus 4 is minus 2 into minus 6a plus b, and this is given to be equal to 6. So basically it is 6 into minus 6a plus b equal to 6, cancelling 6 by 6, minus 6a plus b, it turns out to be 1. This is not 0. Some students do like that cancelling it turns out to be 0. This is not 0. When you will divide 6 by 6, it will turn out to be 1, not 0. So important. From over here we get minus 6a plus b equal to 1, and you can see that the very first equation that we have, it can be minus 5 plus b equal to 2, since I have taken common 2 and then divided. So, and this is minus 6a plus b equal to 1. So if we will subtract it, subtracting will lead to the change of sign, so it will get cancelled and it will be 1. 1 equal to value of a turns out to be 1. So clearing the space over here. From over here we get the value of a equal to 1, and since this equation minus 6 into 1 plus b equal to 1, so b value comes out to be 7. So g of x is basically what? X plus 7, right? So our f of x will be how much? Let me take it on the next page only. F of x is, turns out to be what it is? X plus 3 into x plus 4 into ax plus b, and we have figured out that this is x plus 3 x plus 4 into x plus 7, and this is our f of x. So we need to find the remainder when it is divided by x plus 7. So remainder when divided by x plus 7. So it will be, we will be putting it to be equal to 0, and we get from over here that x equal to minus 7. So f of minus 7 we will get remainder. So putting over here we get minus 7 plus 3 into minus 7 plus 4 into minus 7 plus 7 to 0. Yeah, basically it is also a factor only, right? So from here we get that, from over here we get that the value of remainder will be 0. Question, let's say that when a fourth degree polynomial f of x is divided by x plus 6, the quotient turns out to be q of x and the remainder is minus x. And when f of x is divided by q of x plus 1, the quotient is x plus 6 and the remainder is r of x. We need to find the value of r of x. So say f of x to be equal to this thing. This is our divided into quotient plus remainder, and this is our dividend. But it is also given that f of x equal to when it is divided by q of x plus 1, quotient turns out to be x plus 6 and the remainder was r of x. So from here we get that x into q of x plus 6q of x plus 6 plus r of x. We can take q of x terms to be common. Q of x, it will be x plus c, x plus c, and we know that uh, this thing x plus 6 into q of x minus 6 is f of x. So we will be like doing minus 6 then plus 6 and combining it, x plus 6 minus 6, and it will be x plus 6 plus r of x, and this plus 6 over here I have taken, and it will be f of x. We know that this thing is f of x, so replacing it by f of x equal to f of x minus plus x plus 2l plus r of x. So it will get cancelled, and from over here we get r of x to be negative of x plus 2. So this is our answer, and this is the last of the question that I am having. I hope you have enjoyed. I hope you have enjoyed the lecture and you have also understood the concept related to remainder and factor theorem. We have applied in many of the questions. Now you can try on your own from your textbook, or if you have any query regarding any question, and if you have any query regarding any concept, then you can comment down. Thank you. Keep learning maths. Have a great day.